Hello. So today we're going to be speaking about the clavicle. Now, whenever we describe any bone, I want you to follow this pro forma. Firstly, of course, the name of the bone, then the classification, followed by the anatomical position and the side to which it belongs. This is very important. As soon as you pick up the bone from that table, I want you to hold it in the same way that it is present in the human body in anatomical position and with the hand to the side of which it belongs. Okay, so if it's the right clavicle, you're going to hold it in your right hand and in the anatomical position. Then we speak about the morphology of the bone. We usually divide it into different parts like the upper end, the lower end, the shaft. Sometimes, in cases of atypical bones, as in the clavicle, we might divide it into a medial 2/3 and a lateral 1/3, so on and so forth. Now, whenever you're describing the morphology, you can further describe the ends, usually in terms of head, neck, and the epiphysis. The epiphysis could be tubercles, trochanters. There's a couple of other epiphyses that you've learned by now, atavistic, aberrant, etc. Then the shaft is described in terms of borders, surfaces, and prominences, grooves, and ridges. Now understand that the borders in a typical bone are usually three, and so are the surfaces. The prominences are usually tubercles, tuberosities, essentially attachments of muscles or ligaments. The grooves are either formed by the entering of a vessel or the attachment of certain muscles, and the ridges, once again, are usually formed either by an attachment of linear muscles or the attachment of modifications of the deep fascia, which form intermuscular septa. Then we speak about the attachments. Now, in an undergraduate syllabus, we do not really worry about the attachment of each and every ligament. So muscle attachments are definitely important. It's not necessary to use the word origin or insertion. The word attachment is enough. And in ligaments, there are a few ligaments that you really have to know, and the others you can get away with. Then we speak about the joints involved on either side of the bone. Ossification is again something that is not dealt in an undergraduate syllabus. Sometimes, in certain occasions when it's very important for medical legal purposes or peculiarities, that's when we speak about ossification. And finally, clinical anatomy, which will be dealt in a separate lecture. So the name is clavicle and the classification is modified long bone. Now the word modified holds importance here because a typical long bone, and I would like if you would go through the features of a typical long bone on your own. There's about 7 to 8 points and they're very important, very commonly asked. The reason why the clavicle is modified is because it has a few peculiarities which we shall discuss. Okay, these are, firstly, the clavicle is the only long bone lying horizontally in the body. It lacks a medullary cavity. It is subcutaneous throughout. A few important points of ossification: it is the first bone to begin ossification, the last bone to finish ossification. It has two primary centers of ossification, which is very peculiar, and most of the bone is ossified via the membranous ossification process, except the medial end, which is ossified via the endochondral ossification. So a feature of a typical long bone is that it almost always ossifies through the cartilage precursor. Okay, that's endochondral ossification. Finally, the clavicle is occasionally pierced by the middle supraclavicular nerve. Also note that the clavicle has its nutrient foramen facing laterally. Thus, the medial end is the growing end of the clavicle. Remember, whenever you're describing anatomical position and side determination, always start with the line, hold the bone in such a way that, okay, very important line. I hope you have a clavicle in your hand. I strongly advise anyone going through these videos to have the bone in their hand because that's the best way to get it done in one go and finish it right away. So firstly, the medial end is quadrangular. You'll see that the two ends, one of them is a little more square and prismatic as compared to the other, which is slightly flattened. So the medial end should be quadrangular. the medial two-thirds should have anterior convexity. Okay, hold the bone in such a way that the medial two-thirds has anterior convexity, which means that the S-shaped bone that the clavicle is, make sure that the bulging part of the medial side should bulge anteriorly. Okay. Finally, the subclavian groove, the conoid tubercle, and the trapezoid ridge face inferiorly. Let's have a look at all of these three closely. This is the right clavicle as viewed from above. This is the sternal or the medial end, which articulates with the sternoclavicular joint, which also involves the first rib. This is the lateral end or the acromial end, which articulates with the facet on the acromion process of the scapula. Okay, this is the posterior aspect of the bone, and this is the anterior aspect of the bone. As you can see, there's not a lot of prominences in the superior aspect, but on the inferior aspect, you see a groove in between, which is the subclavian groove. Medial to that, you see an impression for the costoclavicular ligament, and laterally you see a conoid tubercle and a linear trapezoid ridge, which give attachment to the coracoclavicular ligament, as we shall find out. Okay. Now this is the same orientation, but now we have some colors as attachments. Okay. So on the superior surface, medial end, posteriorly we have attachment for the sternocleidomastoid, and anteriorly the pectoralis major. If you trace it laterally, posteriorly we have attachment to the trapezius muscle and anteriorly to the deltoid muscle. Inferior surface, once again, anteriorly the pectoralis major, posteriorly a few fibers of the sternohyoid muscle, and on the facet here we have the costoclavicular ligament, which attaches to the first rib. The blue colored subclavian groove is filled by the attachment of the subclavius muscle, while on the green side laterally you have the conoid and the trapezoid parts of the coracoclavicular ligament. Let's head to the 3D lab and get a better orientation of how these muscles are attached to the clavicle. Okay, so the right clavicle is what I'm going to isolate. Okay, just be oriented with how it articulates with the sternum here to form the sternoclavicular joint, and the scapula here to form the acromioclavicular joint. Okay, also observe how the medial aspect has anterior convexity. Okay. Right, so this is the right clavicle, and now we have it in the anatomical position. Okay. Let's add some color to it. So the light green is essentially the shaft, the cobalt blue is the sternal end, and the mauve is the acromial end. If you look at the undersurface, they haven't really colored the subclavian groove, but they have added a little bit of yellow to the conoid tubercle and trapezoid ridge. Right, let's quickly check out the muscle attachments now. Okay, first we're going to deal with the medial aspect. I'm just going to draw a line to divide it into a medial 2/3 and a lateral 1/3. Great. Now, medial 2/3, anteriorly you have the pectoralis major. You can see how the clavicular fibers are on their way towards the humerus, and posteriorly, more on the medial aspect, you have the sternocleidomastoid. Okay. Now laterally, anteriorly, you have the clavicular fibers of the deltoid, and posteriorly, the insertion of the fibers of the trapezius. Let's see what that looks like. I hope you can now kind of start forming the entire right aspect of the human form. Can you see that? The neck as well as the chest muscles can be seen here. Okay. Finally, let's have a look below. That is the subclavius attaching to the first rib, thus stabilizing all the movements of the shoulder. So these are the muscle attachments on your clavicle. let's go back to the presentation. Now, we're not going to discuss clinical anatomy in detail, but what you see here is a very peculiar condition which is characterized by the complete lack of clavicles, a failure of the development of clavicles. This is known as cleidocranial dysostosis. As you can see, the shoulders can completely droop and come anteriorly because of the lack of the clavicles. One of the functions of the clavicle is actually to act as a strut so that the entire upper limb can freely move away from the axis or the torso of the body. Hence, clavicle is an evolutionary thing that is seen in bipedal organisms. The other thing is the fracture of the clavicle, which will be discussed in detail later. But just note that the fracture happens at the weakest point, which is almost always the junction of the medial 2/3 with the lateral 1/3. And the lateral end of the clavicle displaces below because of the weight of the upper limb that is transmitted through the coracoclavicular ligament. Thank you so much for listening, and I'll see you in the next one. As always, don't forget to like, share, subscribe, follow, but most importantly, don't forget to study.